All right, so for today, what we're focusing on is the multiplication and division rules for integers. The nice thing with multiplication and division rules is they are identical. It's not like addition and subtraction where they have different rules. Multiplication and division rules are identical. So you can even write down here, it's multiplying integer rules, and this is also multiplying and dividing. Multiplying and dividing. These are the same rules. So if you see multiplication, you can also see division symbols. Either one. It works for either or. If you see multiplication or division, it is going to be the same. Multiplication and division are going to be the same rules for positives and negatives. No. Obviously, because 6 divided by 2 is not the same thing as 6 times 2, right? Okay, they're different answers, but same signs, similar signed rules. So what we're stating here is if you are dealing with a positive and you are multiplying or dividing by another positive, you guys already know this. You've dealt with this since you were in elementary school. When you multiply positives together, it gives you a positive. If you divide positives by a positive, it'll give you a positive. But we don't just have positive numbers. Sometimes we have negative numbers. So if we're dealing with a negative and we're multiplying or dividing by a negative, that is also going to give you a positive. And here's what I like to tell students. When you think about it, if you take a positive symbol, so you don't have to write this down, I just want to show you. If I take a positive symbol and I take another positive symbol, and I were to break these symbols apart, how many lines does it take for me to draw a positive sign? 2 lines, right? I have a line here, and then I have another line that's going to go this way, right? And they're going to overlap. Same thing here. I have a line here and another line here, and it's going to overlap. So I can create positives. I have enough lines to create only positive signs, right? I have 4 lines. I can piece those together to create more positive signs. But here, I have a negative sign and a negative sign. A negative sign and a negative sign is 2 lines, right? How many lines does it take to create a positive sign? Just 2 lines. So I can piece those 2 together to create a positive sign. So double negatives. A negative times a negative is going to equal a positive value. If you look at this one where it says positive and a negative, I have a positive sign and a negative sign. How many lines do I have? 3. I have 3 lines. So do I have enough to make only positive signs? No. It takes 2 lines to make a positive sign. So I have 2 lines here, but I don't have enough lines here to make another positive sign. So my final answer is going to be a negative. Same thing for the bottom one. If I have a negative and a positive, I have enough lines to make one positive answer, but I don't have enough lines to make another positive. So it's going to equal a negative answer. Okay? So if you look at the symbols, the number of lines the symbols have, when you've got only one negative, you don't have enough to make another positive with it. So that's why we've got our positive signs times or divided by our negative signs are always going to equal a negative answer. A negative sign multiplied or divided with a positive sign is going to equal a negative answer. Now, if this gets too confusing to remember, you can always draw at the top of your papers this little triangle. Okay, we call it the integer triangle. And how the integer triangle works is at the very top of our integer triangle, we have a positive sign. And at the very bottom of our integer triangle, we've got 2 negative signs. And whenever you are multiplying or dividing, you just cover up what signs you're using. So if I say, hey, I'm multiplying a -5, so I'm going to cover up a negative sign, and I'm going to multiply it by a positive 2, so I'm going to cover up my positive sign. The only symbol that's still left showing is a negative. So that means my answer would be a negative. If I say, hey, I'm going to multiply a negative by another negative, then what answer am I going to get? A positive, because the positive is the only thing that's left showing. Okay, so the triangle helps a lot more with making sense. So we're going to take a look at these bottom problems here. We have a negative 3, and we're multiplying it by a positive 2. So again, I want to make note of the fact that I am taking a negative value, so I'm going to put an N, and I am multiplying it by a positive value, so I'm going to put a P. So if we take a look again at our triangle here, I'm going to take a negative, so I'm going to cover up a negative, and I'm going to multiply it by a positive, so I'm going to cover up my positive. What kind of answer am I going to be remaining with? CJ? A negative. So I'm going to put down that a negative times a positive is going to equal a negative. So I know that when I multiply these two numbers together, my final answer needs to be a negative. So all I really need to focus on now is what 3 times 2 equals. What's 3 times 2? 6. So when I do negative 3 times positive 2, I'm going to get negative 6. Okay, number 2 is another way of writing multiplication. When you see parentheses around a single number, and it's side by side with another number, that's just multiplication. Same thing with this little dot right here. This dot in between them, that's a multiplication dot as well. Okay, then down here, 4, 5, and 6, these are all ways of writing division problems. You have your typical division symbol, but you also have your fraction bar. Fraction bars are also division. So we're going to do number 4 together, and then I'll let you guys do 2, 3, 5, and 6 on your own. But let's take a look at problem number 4. For problem number 4, we have negative 20, so that's a negative. And we're going to divide it by negative 5, so that's another negative. So if we do a negative divided by a negative, negative divided by a negative, if I look at my triangle, I'm going to cover the negative and the other negative. So what does that mean is left, Jordan? Positive, right? Positive 4. Okay, we know that this is going to come out to a positive, and when we do 20 divided by the 5, that gives us a 4, so positive 4. Go ahead and do 2, 3, 5, and 6 on your own. If you've already done it, fantastic. Just wait. Yes? You can just write 4. Okay, that's a good question. He wanted to know, do you have to write a plus sign in front of it? You do not have to. When we did that at the beginning of unit, it was just to indicate that they are positive, but if it doesn't have a sign, we know it's positive. Okay, who wants to share what they got for number 2? Negative 5 times negative 4. Damien? Positive what?
I just put a piece.
Okay, but we also want to work it out. We want to do 5 times 4. CJ? Uh-huh. 20, okay. He called on his lifeline. Bubba helped him out. Okay, so we got 20. So we do have, Damien's right, we do have a negative that's being multiplied by another negative, and that's going to come out to a positive. So he is correct with the positive. And then when we multiply the numbers, negative 5 times negative 4 is a positive 20. Okay, what about number 3? We have negative 20 times negative 6. What do we get there? Jordan? 120, positive 120, right? We have a negative that's being multiplied by another negative. That's going to come out to a positive. So then we just focus on the numbers. 20 times 6 is 120, positive 120. Okay, for problem number 5, we have 24 over negative 6. That's a division problem. 24 divided by negative 6. Phoenix?
Negative 4.
Negative 4. Very good. We're focusing on doing a positive that is now being divided by a negative. Positive divided by negative gives us a negative answer. Okay, so we know we're going to get a negative answer, so then we just do 24 divided by 6, which is 4. Negative 4 is our final answer. Okay, for problem 6, we have negative 32 divided by a positive 4. Christian? Negative 8. Very good. So we have a negative, and we're dividing it by a positive. Negatives divided by positive is a negative. Okay, so then we just go ahead and divide, and we get negative 8. Now, when in doubt, you guys get to have a very useful tool in front of you. You guys get to use what? Calculators. You get to use your calculators to double check to make sure that you've got the correct answers. But it's always good to know the rules at the same time, because if you mistype something, okay, and you're like, okay, well, I know the answer is supposed to be a positive because I've got 2 negatives, but then it shows you a negative in your answer on your calculator, you should be like, well, wait, hold on, I thought that was supposed to be a positive. Double check. Oh, I forgot to type that negative sign. Make sure you know your rules, okay? All right, let's flip it on over to the next page. Vocabulary. Remember we said vocabulary is very big in this unit. So here's some vocab terms that mean multiplication and division. So we're going to start with multiplication. We've got some simple terms that you guys should always have known. If you see the word multiply, if you see them say you're going to multiply, then you're going to multiply, right? If we see times, if we see the word times, that means we're going to multiply. The product is a multiplications answer. So when we do a multiplication problem, we get the answer. We call that answer the product. So it means you're multiplying. Now, the word by and area, those are ones that people don't see very often, but by also means that you are going to be multiplying. Now, these 3 words that are left mean you're not only multiplying, but you're multiplying by a very specific number. So if you see the word double, what number are we multiplying by? If I say I'm going to double something, we're going to double it. What are we multiplying by? Phoenix? Twice, right? Times it by 2. If we say double, so, and then he also said twice, right? Twice also means you're going to multiply by 2. What about triple? What does triple mean we're multiplying by? 3. Triple means you're going to multiply by 3. So those words are very specific numbers that you're multiplying by. Then we've got our division problems. For division words, you have some very simple ones like divide. How much does it go into? Those are some basic terms. When we say we're breaking something up into equal parts, we want to know how much does each person have. Okay, how much does every person have? Those are going to be equal parts or division. Quotient is the answer to a division problem. When we make a ratio, that's a division problem. And then half. If I take half of something, I'm dividing by what specific number? If I'm taking half, I'm dividing by what, William?
You're dividing by 2.
By 2. Very good. If we take half, it means we're dividing by 2. All right, so these are some really good terms to know so that when you're looking through a word problem, you know how to break it down into each of its little components. So let's take a look at number 1. Elena overdraws $25 on her account. What does overdraw sound like it would be? Would that be a positive or a negative? If we're negative, right? We're overdrawing from our account. That's a negative thing. That means we're taking out more money than we actually have. Okay, we took out $25, but we didn't have that $25 in the account, so we took out too much. And not only is she going to do that today, but she's going to do it every single day for the next 4 days. Now, 4 days, do you think that's positive or negative? Positive, right? Because it's days, isn't it? Here's one thing I want you to write at the top, real quickly before we move on. At the very top, I want you to write down, people and time. People and time are always positive. Whenever you are looking at a problem and the problem has a number of people in it, or it has a number for time, like you've got this many minutes or hours or this many days or weeks or years, those are always positive numbers. Okay, people and time are always positive, so you should have that written at the top of your notes. Everybody good? Okay, so let's take a look then. Since we have that written at the top of our notes, people and time are always going to be positive. So we have a negative 25 and a positive 4. Now, she's going to do this every single day for 4 days. Every day for 4 days. That right here means we're multiplying. When she's going to do this specific thing every day for this specific number of days, that's a multiplication problem. So we're going to multiply negative 25 times a positive 4. Negative 25 times a positive 4. Okay, so then we can just use our calculator for that. We can do negative 25 times 4, and that's going to give us negative 100. Once we have it broken down in our, to what the problem's going to be, we can then just work it out in our calculator. Okay, let's take a look at number 2. Alex's team lost a total of 55 yards. Lost 55 yards. Positive or negative, guys? Negative. Lost a total of 55 yards. That's going to be a negative. Now, all 9 players lost the same amount. Players, are those positive or negative? Positive. Why? Because they are people. And people and time are always positive. So all 9 players lost the same amount. I want to know, how much did each player lose? How much did each player lose? So notice that in the question, and I'm saying, hey, they all lost the same amount, right? So I am breaking it up into equal parts. The fact that everyone lost the same amount, we're breaking it down into equal parts. Shh. Remember, equal parts means it's division. Equal parts means it's division. So we're going to take negative 54 and we're going to divide it by the positive 9. Yes, dear? Good, thank you. It's going to equal negative 6. So negative 6 yards per player. Each of the players lost 6 yards. Okay, you are identifying not just whether we're dealing with positive and negative numbers, but you're also identifying what kind of operation are we dealing with. Are we multiplying in this problem, or are we dividing in this problem? Okay, let's take a look at number 3. For number 3, temperature falls 3 degrees. If it falls 3 degrees, is that positive or negative? Negative, right? Falls 3 degrees. That's going to be a negative 3. It's going to do this each hour for 8 hours. 8 hours, positive or negative? Positive. Positive, because it is time. 8 hours is time. Okay, we want to know, what's the total change? What is the total change? So we're doing this each hour. This right here indicates to us that we're going to multiply them. Now, I had one student ask, they said, well, hey, you've got each in this problem, we have each in this problem. Both of these have the word each in it, don't they? But one of them was division, one was multiplication. So I want you to pause for a moment and come back up to here. Underneath multiplication, if you see the words per, each, and every in the problem, If you see the words per, each, and every inside of the problem, that's a multiplication. But if you see the words per, each, and every in the question, then that's a division problem. Oops. So here's what I mean. For problem number 2, we had the word each inside of the question. How much did each player lose? But look at number 1. We had every in the problem, not in the question, was it? The word every was in the problem, and now it's multiplication. For number 3, the word each was in the problem, not in the question. So it's multiplication. So there's a difference. Per, each, and every can mean either multiplication or division. You'll know it's division if it's inside the actual question. Does that make sense? You see those keywords inside of the actual question, it's a division problem. If it's outside the question, it's a multiplication problem. So we're going to do -3 times +8. -3 times +8. I don't have a clipboard. Sorry, honey. So -3 times +8. Jordan? -24. Very good. -24 degrees dropped. -24 degrees dropped. All right, let's take a look at number 4. A submarine dives 20 meters each minute for 15 minutes. What is the total change in depth after 15 minutes? So let's highlight our important information. First, I need to highlight my integers. 20 minutes, is that positive or negative? Negative, because it dives. Dives 20 meters. Dives is going to be negative. What about 15 minutes, positive or negative? Positive, because that is time. Okay, now we need to figure out, are we multiplying or dividing? Multiplying or dividing? Brian? Multiplying, because we see the word each, don't we? We see the word each, but is it in the question? No, it's in the problem. We see the word each, but it's in the problem, not in the question. So this is multiplying. So we're going to do -20 times +15. -20 times +15. And you should be using your calculators. What's -20 times 15? Amara? Not quite. Get your calculator, okay? Get your calculator. Jordan? -300. Guys, make sure you've got your calculator out so that you can use it. All right. What I want you guys to do is flip it on over to the next page. You're going to do problems 5 and 6 on your own. Do 5 and 6 on your own. Problem number 5. For problem number 5, Max lost 24 pounds in 8 weeks on his new weight loss plan. What was his average change in weight per week? What did you get, CJ? Okay, you highlighted lost 24, because what does that mean? He lost 24 pounds, right? That's a negative, -24. What else did we highlight? What else, William?
We highlight per week.
Okay, per week. Why did you highlight that? What does that mean?
That means it's division.
It's division. Very good. He highlighted per week because it's division, because it's inside the question. So we know division. And what's one more thing we could highlight? What's something else we could highlight? Jordan? 8 weeks. And we can highlight that green because that's going to be positive. So we have the problem -24 divided by 8. And what would that equal then? Liliana? You gotta divide. You gotta divide. Negative 24 divided by 8. Try it again. Do negative 24 divided by 8. Shh. Hands down, please. I'm waiting on somebody who's trying. Negative 3. Very good. All right, negative 24. Christian and Amara, you guys are going to get yourselves in trouble if you keep talking across the room to each other. All right, number 6. Keither borrowed $4 a day until he borrowed a total of $88. How many days did he borrow money? So let's start highlighting some things. Who can tell me what's one thing to highlight? Brian? Borrowed for $4 a day, right? We can highlight that as a negative because borrowing money is a negative value. So we've got negative 4 that we're dealing with. What else can we highlight? Damien?
A day.
A total of $88 also borrowed, right? We borrowed a total of $88, which is also a negative. So we've got a negative 88. What operation are we doing? He did this for until he had a certain amount. What is it going to be, William? Not quite. Division. It's division, right? He did this for a number of days until he had a total of this amount, right? We want to know for how many days, how much per day did he, or how many total days did he have? So this is going to be a division problem. This is going to be a division problem. Now, negative divided by negative is going to come out to a positive. We're going to have 22 days. Remember, days is always positive. Okay. Now, real quickly, I want to go through this last little bit. This last little bit here is really important for you guys to focus and understand. So take a look at these last problems here. I have what looks like the same fraction written over and over and over again in different ways. But one of these is not the same answer as the other 3. One of these fractions here is not the same answer as the other 3. So let's go over and figure out which one is not the same. So for my first fraction, I have a negative sign, but it's written in front of the fraction. It's not assigned to either one of the numbers, is it? It doesn't say negative 3. It doesn't say negative 5. It just says negative, and then we have 3/5. So when we have that, if we write that as a division problem, what that looks like is you've got a negative sign, and then you have inside parentheses 3 divided by 5. Shh. Inside parentheses, we would have 3 divided by 5. Now, if I do 3 divided by 5 on the inside and put a negative on the outside, my final answer is going to come out to a negative 0.6. So even though the negative was not assigned to one of those numbers, my final answer in a decimal form is still a negative answer. Now, if we take a look at the second one, this time I do have the negative sign attached to one of the numbers. I have it saying it's a negative 3 over a positive 5. So when I write the division problem, I would write it as negative 3 divided by 5. Boys, you're going to have a test question just like this next week. You want to make sure you know how to do this. This one has me doing negative 3 divided by positive 5, which is still going to equal negative 0.6. Now, if I look at my third example, I have a negative sign, but this time it's attached to the denominator, the bottom. So it's positive 3 over negative 5. So that means I'm doing 3 divided by negative 5. And that is still going to equal negative 0.6. So if we take a look, all of these are still going to come out to the exact same answer. until we get to the last one. What's different about the last fraction?
It is.
Damien?
It both has negatives on both of them.
You have negatives on both of them, right? We have 2 negatives this time. For this last one, we have 2 negatives. Those 2 negatives, when I do -3 divided by -5, remember we talked about it. Negative divided by negative is going to come out to a positive 0.6. Shh. So having 2 negatives in your fraction is going to give you a different answer than having 1 negative with the fraction. It's okay for the negative to be in front of the fraction. It's okay for the negative to just be at the top or to just be at the bottom. What's not okay is to have a negative at both the top and the bottom at the same time. Then that would not be a negative fraction anymore. That would become a positive. Any questions? Okay, we're out of time, so you guys can pack up. If you did not finish your quizzes from yesterday, you have until the end of the day today to get it done.